Okay, hi everyone. So today let's discuss this interesting problem. So it says in a factory it is desired to lift 2000 kilogram of metal through a distance of 12 meter in 1 minute. Find the minimum horsepower of the engine to be used. Fine. So देखो एक metal है and the mass of the metal is 2000 kilogram and you have to lift this metal by a distance of 12 meter, right? So you have to use some kind of engine. So what will that engine do? It will apply some force on this metal, right? It will apply some force on this metal in the upward direction so that this metal can be lifted by a distance of 12 meter in the upward direction, right? So देखो एक तो capital F लगेगा applied by the engine and there will be a weight of this metal in vertically downward direction. So these two forces will act on the metal. So if we use work energy theorem, it says work done by all the forces is equal to change in kinetic energy final minus initial. So initial kinetic energy of the metal will of course be 0 because you have to lift it. So initially it was at rest. So what is the work done by all the forces? Work done by capital F plus work done by mg, that is equal to your final kinetic energy. Now work done by mg, I can write it as minus of delta u, minus of change in gravitational potential energy, right? So kf, that is work done by F, or you can say work done by the engine, right? Because this capital F is applied by the engine, so therefore work done by engine is coming out as delta u plus final kinetic energy. And what is delta u? mgh, or you can say h final minus h initial. This is your h final, 12 meter above the ground, and this is your h initial. So this height is 12 meter, so h is 12 plus final kinetic energy. This is the work done by the engine. Now we have to calculate the power, right? So what is power? Power is work upon time. So time is also given 1 minute. So we can write power as mgh plus kf upon time. Now he has given that find the minimum horsepower. So you have to minimize this power. So you can see m is constant, g is constant, h is constant, right? Time is also constant. Final kinetic energy we don't know. So if you have to minimize the power, then you have to minimize the final kinetic energy, and kinetic energy is always greater than or equal to 0. So we can say the minimum value of power will be when there will be minimum value of the kinetic energy, which is 0. Final kinetic energy of the block is 0. Final kinetic energy of the metal is 0, then the power needed will be minimum. So minimum power required to lift that metal will be mgh upon t. Now you can find out the numerical value. m भी दिया हुआ है, m 2000 is given, h is given 12 and time is given 60 seconds. Remember you have to convert it to HP, because this will be in watt, so you have to divide it by 746 to convert it to HP. So you can write 746 in HP. Fine, I think it's clear. Let me know if you still have any confusion, we can discuss further. Okay guys, keep working hard, best of luck.